today's video, we are going to be looking at parallelograms again. We're going to look at a little bit more. So review from yesterday, we know that the opposite sides are going to be congruent. By the definition, the opposite sides are going to be parallel. Opposite angles are congruent, and consecutive angles are going to be supplementary, again because of that same side interior relationship coming from the parallel lines. We are going to introduce one more new property today, and that new property is that the diagonals of the parallelogram are going to bisect each other. So both diagonals are being bisected, not just one, but both, which is going to make things easier. We don't have to worry about which one. So when I look at the parallelogram ABCD, because it tells me it's a parallelogram, I know I can apply any and all properties that we've learned about a parallelogram. This new property that we just learned said that the diagonals bisect each other. If they are going to bisect each other, AC is a diagonal, which means AC is going to be cut into two equal pieces. BD is a diagonal, which means we're bisecting and cutting BD into two congruent pieces. So when I look at what I know, and based on the information that I'm provided, I'm given these three segments. The two segments that go together that are congruent are these two. So this right here is actually extra information that's going to be there to distract us and see if we do something wrong with it. All we need to know is that the 7x plus 4 is going to be equal to the 3x plus 36. And again, I know that because the diagonals are bisecting each other, and bisect means that we're going to cut it into two equal pieces. So to solve for x, we move our 3x over, giving us 4x plus 4 equals 36. To move that 4 over, we do the opposite. So since I'm adding, I subtract. 4x equals 32. Last, we divide by 4. And we find that x is going to be equal to 8. Next one. Again, looking at this new property that we've talked about today. Given the parallelogram ABCD, we are told that AC, this entire diagonal here, is going to be 10x minus 2. And then part of that diagonal, just AE, is going to be 2x plus 1. We want to solve for x. So thinking about that property, the diagonals bisecting, I know that these two pieces are congruent, which I know nothing about. I also know that this segment has to be congruent to this segment, so these are two equal pieces. I have AE. I'm not going to say that AE is equal to AC. 2x plus 1 is not equal to 10x minus 2. Because remember, equal means the same amount, and AE is just part of the whole AC. But because it's bisected, because we know those two segments are congruent, if this is 2x plus 1, then this also has to be 2x plus 1. So we can either add it twice, or we can say that it takes 2 of those segments, 2x plus 1, to equal 1 of the whole segments of 10x minus 2. We distribute our 2 to get 4x plus 2 equals 10x minus 2. We move our 4x over. Since we have a positive 4x, to move it we subtract. 10 minus 4 is 6. Since we're subtracting 2, that means that we have to add 2 over. 4 equals 6x. Now we want to be careful here. If we have 4 equaling a 6x and we divide by 6, and you put that into your calculator, you get a messy decimal. And remember, we don't have messy decimals. If it's a messy decimal, we have to give an exact answer. So we reduce our fraction to get 2/3 as our value for x. All right, here comes our last problem. Solve for all of the different variables of the parallelogram. So this is back to what we kind of looked at in our video yesterday. We have to use parallel lines. Definition of a parallelogram is opposite sides are going to be parallel to each other. And we're going to need that to use our parallel line properties. Let's start with some easy stuff. Let's think all the way back to Unit 1. And we have vertical angles. So if this is 68, then this is also going to be 68. Then we think about, I have a straight line. If I have a straight line, then these two angles right here are forming a linear pair. And a linear pair is supplementary. They equal 180. So 180 minus 68 is going to make y 112. And if y is 112, that means that t is 112, because once again we have those vertical angles. So just using our old school methods way back from Unit 1, we can find those four middle angles, which is going to help us. 42, 112, if I want to find x over here, this is forming a triangle, and I know all triangles add up to 180, so 180 minus 42 minus 112 is going to leave us with 26. All right, so we've got a lot of easy stuff. Oh, we can find this easy angle over here too. Again, triangle sum, we have a triangle right here. So if I do 180 minus 34 minus 68, we find that z is going to be 78. Now we're going to think back to our parallel line unit. We have the top and bottom parallel. We have got the left and right parallel. So we're going to use those alternate interior angle properties again. If this right here is 42, the alternate interior angle over here, u, is going to be 42 as well. Using those alternate interior angles again, if this is 26, that means that this has to be 26. If this is 34, then this is going to be 34. We're just going to keep using that all the way through. Z over here is going to be the same as R over here, which is going to make this 78. So we can finish up all of those missing angles just by using our alternate interior angles of parallel lines being congruent theorem from way back when in first semester. All right, and that is it for the second day of parallelograms, where we learned about that second, or that new property, that diagonals are going to bisect each other.